the pull request. So I looked through attendee list. I don't seem to find Lantau here. So basically, I adopted Lantau's advice. So if you read the comment I pasted, basically, so when the GC finds potentially unhealthy symlink, we don't just delete it upfront. So we query CRI for the container status. If the container is gone, then we can remove the symlink.
Yes. Mm-hmm.
Yeah. So maybe you and Lantau can take a look.
Sure. Okay, I didn't see Lantau join either, and so I'm going to take a look, and also we'll ask Lantau to take another look.
Mm-hmm. So
okay.
Do you have any other feedback?
No.
It looks like it's querying the container stats API. Is there a reason why it's doing that instead of just asking for the container itself?
I'm not sure I get your question. Are you suggesting a different API?
I'd have to look at it. I haven't looked very
okay.
closely.
All right.
But probably. I don't think container stats is meant to be the source of truth for whether or not a container exists or not.
They want to ask the container is running or not. So it's not like the container exists or not. It's like the container still is running state, or it is the data state.
So I also attached say a log from one run. If you read a few comments down in answer to Derek, let me go there. So
yeah,
I can.
I think last time Derek and I both asked testing. So can you reproduce the problem? I saw you provide some information. You manually provide some information.
Oh yeah, so it's in this link. So we can see there are, these two lines were pretty close, but so the first line says is a bit long. You need to slide. So it says container still exists. Now removing symlink, and after this is not even 1 minute. This is about 25 seconds later. The kubelet side removed the container. So I think I also summarized above this comment. I summarized the requirement for a E2E test. Well, in case you don't have time to read it, I can briefly summarize. So in the existing test, which is a log path test, so we have an embedded container watching for the logger for expected log snippet. However, for this, for the new E2E, the requirement is different. So the container, this busy box container, we need to list other container, because this busy box container is supposed to be live during this E2E test. So I can, I'm not very familiar with E2E test framework. I don't know if, say, we have a busy box container in one pod. Do we have some way to list, to query container status either in the same pod or a different pod? On a more in the general sense, so I listed. I mentioned sidecar. So if we have a sidecar container, that can be injected into, say, some other pod, because this log rotation versus symlink removal can happen in other tests. But we know a sidecar mechanism is not there. So even within the same pod, I'm still looking for some API, either through a kubectl or some other API which can give me this information. But in summary, so in my second paste in the chat, we can see the two log lines. So the first coming from runtime GC, the .go. So I feel runtime GC.go, that's where a judgment can be made. Whatever E2E test does, it will be mimicking a similar logic, basically detecting whether live containers log symlink is removed. Yeah, so maybe somebody more familiar with E2E test can give me some highlight. But overall, I think this E2E test, so it's good to have, but maybe the test itself can be decoupled from the fix, from the actual fix. So during my day job, I looked at some internal tickets where a QA mentioned, oh, in the log, he or she saw a certain phrase and marked the ticket pass. Yeah, so that's the summary so far.
Any question?
I looked at it a bit, and I have a different suggestion for how to get whether the container is running or not at this point. I'm just going to drop my comment on the PR, and we can go from there.
Okay, cool. So any other suggestion and question? And so I still think about we need to have the test, but we can carry offline discussing and to see how to add the proper test. I think that's the way to get those information. Yeah. Okay, so let's move to next topic. Next one, David, do you want to temporarily pause to provide the advice and to talk about the allocatable eviction for the pit?
Yeah, so I've been opening some issues trying to improve some of the out of random Linux resource eviction that we have. But one of the things that I was thinking about just in terms of the bigger picture is that each time we try and do eviction on a new resource, we are adding stats for that resource to the summary API. And if we want to be able to do eviction on file descriptors and tasks and PIDs and all of these various resources, we may not want to actually add all of those to the summary API. So I was actually hoping Derek would be here, so maybe I'll ping him offline. But I'm also just curious if anyone has opinions on, I was thinking it might be appropriate to have an internal kubelet API for passing these stats to the eviction manager instead of using a summary API. But at the same time, I can also see that if the kubelet is performing eviction on, say, file descriptors, then someone who is monitoring the node should be able to tell whether it's starting to run out of file descriptors or not. So I could see it both ways, but was just looking to raise it and see if there were any opinions about how we should go forward.
So I want to ask, are we going to still make the summary API as the monitoring API for the Kubernetes? And then we have the core metrics API for the control, like the Kubernetes, the controller. I think that's basically original, my approach I suggested, then we move toward, but we never really finish, but we still move toward that one.
I would say that's the current state. we have a core metrics API that's, sorry, I'm getting feedback, it's weird. So we do have the core metrics API, which is just CPU and memory, and that's what's required for auto scaling and such. I would definitely say that the summary API is a monitoring API, but it does have a dual purpose today, which is it's for monitoring your stuff as well as for the kubelet to consume internally for things like eviction or other processes. So I'm basically asking if we should split those two up, or if it makes sense. Yep.
Okay. So there's the before we talk about Kubernetes only have their controller, like the metrics for the core control API, controller API, right? Which is mean like core metrics API. Then summary API as the monitoring API could be exposed by export by some other daemon. Like for example, we could have like the some other plugin could be run shared weather as the daemon side. So just like what you just said right now, we are actually summary API still serve the dual purpose. So actually it's still half of the control management. And even Kubernetes is the least, like the lowest, like controller, right? So then, which means like we cannot really eventually make the summary API can be replaced and exported by other daemon on the node, right? So you have.
You're saying if the kubelet has a dependency on the summary API, then we can't have other things exposed. I agree with that. I think I could definitely see a world in which the kubelet is managing resources that it doesn't expose metrics about, and doesn't necessarily collect metrics with the same pattern that it does today, which is a 10 to 15 second interval. It very well could only, for example, periodically check the node and allocatable level PID usage or file descriptor usage, and save querying for container level PID or file descriptor usage for just when it's doing the out of eviction ranking. So I think if we're concerned about performance, like we could still minimize that, even though the kubelet still has some knowledge of how to monitor and manage those resources, and still make room for some external thing to manage them. And I'm also not asking a super duper long-term question. My question is just for the few resources that we want to manage today, should we add those to the summary API, or should we start to make those sort of internally managed resources that only the kubelet knows about?
Okay. Any comment? Any question related to this one? So I believe, David, I believe you are going to follow up with the Derek.
Yeah, I think I'll follow up with Derek. And if you have any comments, I'll take those too.
Totally. But I think the Derek last time have some comment related to this topic. So you want I personally, I think we can keep up the internal resource metrics and by Kubernetes based on, because we are doing a lot of the resource management and the controlling work. But I believe Derek also have the concern, because a while back we reached some agreement, and we push very hard on those agreements. Right now, actually, like we started to violate some of those agreements. So I think there's the middle ground, and we can reach out. So start from the discussing with Eric, because I think we persuade him to to reach that agreement. So, okay. So let's move on to the next topic. So next one, it is it's typology management enhancement. We are going to resume last week's discussing. So sorry, I couldn't pronounce your name correctly.
Yes, hello. You can call me Chris. It's a version in English of my name. And is there a possibility to share my screen like last time?
Oh, I think so. Let me do. Because I'm the first time using this web client. So let me see. Sorry.
It's okay.
No wonder earlier nobody shared the screen. I was just thinking, oh, what's going on here? I don't know because I'm not familiar with this one. Okay, let me see. Oh, yes, you can now. Try.
Okay, it's working.
Yes.
Great. Okay, so today I would like to discuss with you regarding Topology Manager update that recently CAPS PR was raised. It was last week. And I would like to give you a presentation about those changes and to discuss about this, raise some questions, get feedback. Okay, let's get started. First, I would like to tell you about related work and discussion that was regarding this topic. I will give some links to the past discussions. Later, limitation and challenges in this area and changes we propose to resolve these challenges. Some issues that can also be solved by this solution, some extra information in the appendix, and then some QA time. We have a lot of time, so I think there will be a time for discussion. There were discussions with community on the SIG Node on the Slack. In the presentation, you can find the link here. Also, there was discussion on Google Docs document, and in this document is the same idea that is presented in this proposal in this presentation. There was also a discussion about some alternative ideas. You can find it here. And also CPU manager policy, new CPU manager policy, and memory manager are related, but this will be presented in the next weeks. Also in the presentation, you can find the CAPS link if you will lost it or miss it. So let's start with limitations. Right now, when Kubernetes calls admit function on Topology Manager takes container from the pod, get hints from hint providers for resources that this container requests, and then uses the policy to merge those hints. And right now, only one policy from this above can be selected, and this is the first limitation. So pods requiring different resource topology cannot be bound to the same node if they require different policies. And this policy is merging hints and generating the best hint and then admit message and provides it to the topology manager, and then topology manager based on the message allocates resources or not. And steps from 2 to 6 are performed per each container. And this is the second limitation. Hint calculation is done for each container in a pod individually. And this gives us some challenges. The first challenge is to deploy pods with different topology requirements within a common worker node. So let's get an example here. We have a pod A that requires allocation of resources with single NUMA node policy and pod B with restricted policy. So to schedule them to the right node, an operator must give a label selector, and that will be connected with the correct worker node to assign the single NUMA node pod A to the correct worker node. So here is the worker node on the right, and pod B to the worker node in the middle. And let's imagine the situation when we have a lot of pods that require single NUMA node policy. So the worker node on the right will be overcommitted and fully used, while the other nodes will be nearly empty. So the deployment tends to be inefficient right now because only a particular policy can be applied within a worker node, only one policy. And the second challenge right now is to ensure the allocation of resources from the same NUMA node for multiple containers defined in the same pod. So if we have a pod that has 3 containers, and the first 2 containers get resources from the first NUMA node, and there was no enough resources for the third container will get resources from the third NUMA node. And in such situation where second container would like to communicate with the third container, they will have to communicate through the UPI channel between the sockets. So there will be a degradation of performance. So the solutions we propose are: the first one is extension of pod spec. It is to add a new field in a pod spec that would specify the requirement of topology, and the topology policy will be determined by this field and not the kubelet configuration of a node. In this field, following policies can be specified: known best effort, restricted, single NUMA node, and later present in this presentation, pod level single NUMA node. So as you can see, they are exactly the same as right now Topology Manager supports. And also, if the value in this field won't be specified by an operator, the default value will be none. Also, we would like to introduce some new policies. One on the node level, called dynamic, that would coordinate assignment of resources according to the topology policy specified in a pod spec. So to use this field and topology policy specified in this field, dynamic policy has to be selected on a node level by a kubelet flag. If any other policy will be specified rather than dynamic on a worker node, the topology manager will coordinate resources allocation based on the configured policy. So this policy and pod spec topology policy will not be used. And also the kubelet flag for topology policy will be deprecated in future versions, and default policy of topology manager will be replaced with this dynamic policy. And there won't be issue. There will not be an issue with compatibility, as I said previously, the default value of this policy will be none if won't be specified in a pod spec. And the second policy that we want to introduce will be on a pod level that can be specified only in a pod spec, and this will be pod level single NUMA node. And this is the solution for the second challenge that would support pod level resource alignment to the same NUMA node. And as I said, it will only be applicable through the pod spec. So as you can see on the picture, if we provide our solutions, each worker node can support different topology policy requirements. This new pod spec policy, pod level single NUMA node, will make changes accordingly to the picture. So the situation will shift from the red one to the blue one, and each container in a pod will receive resources associated with the same NUMA node. So how the implementation will look like? Topology manager should be changed to support pod level resource alignment, because right now it is done on per container basis and interfaces are prepared for this. Also, new field should be introduced to the topology, to the pod spec. This is the topology policy field, and new policy on a node level will refer to a new field to determine how to merge hints. And these solutions can resolve some additional issues, like pods that have a different topology requirements cannot be bound to the same node. And as a result of that, an increased number of physical servers would be required. So the higher budget must be spent. And the second issue is that administrators have heavy burden to configure topology policy flag for every server in large cluster. And this also will be solved with deprecating the policy flag. So the plan is to leave the default policy value, which is none, for 1.19 version of Kubernetes, and to utilize the topology policy specified in the pod spec, it would be required to set dynamic policy on Kubernetes startup. And in version 1.20, topology manager default policy would be dynamic, and it cannot be changed at the node level, so the configuration flag will be deprecated, and topology policy for the pod will be specified only in the pod spec. What do you think about it? Do you have any questions?
So should the current node policy be exposed in the node status, so when the scheduler can look at this new proposed field and filter out the pods from the nodes where it cannot be satisfied?
Yes, it is an additional feature.
So I just saw this, your proposal today. I missed the meeting last week, and I've been trying to catch up on it. But I think both he and Kevin and Connor would like to probably review this. We've been working on the topology manager, probably Kevin longer than some others, and also Connor, and probably provide some feedback. But in general, we had already been discussing and thinking about, doing the having a policy that we could apply to a pod. And it sounds like you've already taken some look at that, and that looks very interesting. But I think if you can give us some time to look at that and review it sort of offline, that would be great.
Okay.
Yes, Victor, actually last week we talked about, but it's really high level and for the things, and also cover other topic like next week. So from high level, so I didn't mention your name and all the other people, all the other people's name, because also I'm looking at the people really keen on the topology, and in the past contribute a lot to the memory management, CPU policy, and also management policy, and also topology. So because this is kind of the big change, because like last week I also mentioned a couple of things. One thing I think you cover next week is going to, Chris, you cover next week is going to have the new proposal, because one concern it is we only talk about the NUMA node and the memory. We didn't really talk about the CPU. What it is the CPU. So we last week parentheses kind of like found the 3 different separate level to present here. But actually, to me, if you really care to support the high performance workload and the HPC type of the workload, you have to take all 3 into consideration. And so we want to know those how evolve. Another thing it is I think about you didn't touch base earlier, but Alex asked a little bit. One concern it is, especially you add this multiple policies supported by per node, and I will think about the scheduler will make more controversial decision, which my concern, right? Scheduler don't know those topology, and you add more topology to per node support the final grant decision. So then we may have the node may make a controversial decision, more chance to make that controversial decision than the scheduler. So you end up have the more reject. Think about, oh, I cannot satisfy, and that request, and then you end up could be like the ping pong or what a cascading issue with the scheduling. I don't think about we are talk about this one today.
Okay, if I could quickly just answer those concerns. For the first one, and the compatibility and the high performance and connecting this with CPUs, we have this in mind, and we look for the compatibility and how these improvements connect with each other, and also how this to have the compatibility between new policies and this dynamic policy with CPU manager and new in the future memory manager. And regarding the scheduler, we also try to address this in the CAP. And there is the practical challenges chapter when we described some temporary limitations, for example, that using a controller that would guarantee to bind a pod to a node with usage of new workload or CRD, and maybe some long-driven answer for that problem with making scheduler topology aware.
Chris, are you still there?
Yes, I'm still there. Sorry, that was all about those concerns.
Yes. We are going to follow on the CAP, and also I believe next week you propose next week come back to talk about more, right? About those new suggestion about the CPU management and the NUMA and the memory all together. So I'm waiting for next week. So what about the second question? Maybe I didn't really get what how you answer to the second question about the scheduling pieces.
One more time the question, please.
So we today it is a scheduler, is not a topology a while, right? So used to be we apply the single policy to a load, and so even in that case we it's unlikely node will reject scheduling decision, like the pod say, oh, I cannot find and satisfy this policy. And now we allow the multiple policy apply to single node. And of course, I can see that reason you want to increase of the utilization, and but the potential could be like the scheduler schedule more pods, and each one have some like the level of the different of the topology policy, and then you end up like the node cannot satisfy the requirement and then reject. So you end up have the more like the disagreement between scheduling and also the node. Have we look into those kind of things and have some example and look into?
Okay, I'm not sure if I was heard previously because I was talking about it. In the CAP, in the CAP updates in the PR, we added a chapter called Practical Challenges, where we address this issue, and we present two types of mitigation. The first one is maybe temporary or some custom solution where you can create a new workload type called their topology set or the CRD, or some maybe long-term solution here to make topology aware, scheduler topology aware. And there are two ways to do this that we described in the CAP. And the first one would be with usage of detection of nodes resources topology by node feature discovery, or the second one is to enhance scheduler with scheduler framework. So we've got this in mind, and we know that there will be rejections right now, but it is still to be solved in the future.
So last time I looked at that one, don't have those. Maybe last week we talked, then you update this, or maybe I just missed it because I raised this problem, and I think we didn't say. But the problem it is, can we treat this as the complete solution? And it sounds like we just say, oh, let's just only solve the node problem first, and instead solve the Kubernetes cluster level problem. So can we have some way to think about because I worry, because if you want to make this, it is the scheduler a while, like and you need to figure out what's the API. And now you propose the pod spec extension. And I worry about in the future, you have to make more change on the pod level. So can we have like a high level picture, like how we are going to solve this at the cluster level?
Okay, I understand.
If I am the customer, if I am the user and admin cluster, I mean the admin for a cluster, how I'm going to configure my cluster in certain way, and how I'm going to then I present that cluster to my user. So then there's another way. It is I am the application developer, and how I have a HPC workload, how I'm going to deploy it. So can we solve that problem? I'm okay with like the no complete solution on the scheduler, but at least we need to put instead of say, oh, well, we know there's the problem, then we just put it there in the shared, and then we come back later. My concern it is because we are changing the pod spec API. And in the past, actually, there's the many proposal how to support this one. I mentioned like last week, like the resource class, and to support those things, but we didn't really go further. So I'm worried about just to simplify those kind of things, didn't put into the cluster level communication, because the previous resource class is being pushed back is due to the cluster level. We couldn't to solve that problem. And I mean, we think about we have the good solution to solve that problem, but it got a lot of pushback because it's too complicated, and no good way to support that complex scenario. And so that's why my concern it is, even we think about, oh, here it is, once we have this one, then at the end, we don't have the cluster solution. So I think we should start to thinking about what's the cluster level of how we are going to expand it. Then we can focus on the node solution.
I will add just one small point, which is you probably don't want to make this new kubelet option the default if it's going to require deploying a bunch of extra non-default Kubernetes components to your cluster to get it to work correctly, right?
If you could say which extra components do you mean?
So I was reading through the KEP and it sounded like you needed to deploy a second scheduler that was NUMA aware, or is the proposal also to make the default scheduler NUMA aware?
Okay, right. Okay, I see.
Yeah, just a minor point.
Just while we're talking about that, sorry, my machine rebooted earlier, or locked up, had to reboot. But we are also looking at spending some cycles on trying to add NUMA awareness to the scheduler, but it wouldn't be through the scheduler that's built in now. There's a scheduler framework, so we're sort of investigating that to look at ways that we could make the scheduler smarter about which node it chooses to put the pod on to start with. But we're sort of in the early phases and doing some, prototyping and not really ready to share what we're doing yet because we still have some work to do, but we would certainly bring that to the SIG Node meeting once we make a little more progress and understand that a little bit better. But Dawn, I think you were saying that there were some challenges you would like to see addressed first, and I didn't quite capture all that. Were you saying that we have some issues now with just the topology manager running at the node level that you wanted to see?
No, actually, my concern it is with this new enhancement, we are allowed to apply multiple policy, right? Different policy at a single node to increase of the utilization. Because previously we only have the single policy. So even we don't have like the scheduler, I think about it is the scheduler and also node make the different decision, controversial decision, conflict decision is less, is less frequently. So I'm not that concerned. And so because we talk about the typology a while scheduler before, but we didn't block that one. It's just because it's the single policy applied to the single node. So it is not like, so, but now we have the multiple policy applied to the single node. So, so to increase of the utilization. So you end up could be have like the scheduler schedule because they don't have the typology knowledge, but the node will reject more often. So that's now like the scheduling a while, like topology a while of the scheduling is the more like the key to me right now. So it's kind of, I'm concerned about that one. So I suggest, because I raised this question last week, and I suggest we at least have some understanding how we're going to address that problem from high level. Then we can, of course, we cannot solve all the problem at the same time, but then we can start to focus on this one. I'm a little bit uncomfortable, like we just say, oh, we are going to build, and because we know it's take the years we have to build the topology a while, the scheduler, and we used to have the resource class proposal. I think you met a while through resource management work group, and one of the engineer from Google, Jiaying, actually put a lot of effort that one. And the real blocker actually is not from the node side, it's more from the scheduling side. How we are going to, because it's too complicated for people thinking about to build the scheduling for that one. So that's why I just raised this question. Hope I answer your question here.
Yes, very good. Thank you.
Thanks.
So if I could just ask to sum up, what will be a good approach from my and my team side is to create a big picture with usage of some kind of solution for this scheduling problem with the other changes, right?
Yes.
Great, thank you.
So Victor and Alex and Connor, and I think the last week, some of you here and some is not. So we talk about have a group, because this is a big change, and we'll change how we manage CPU, memory, and also NUMA. And so I hope we have some like the group, like the previous form a group, and to review this one. And so who is going to participate? I don't know. I need to talk to the Derek, and also I believe Derek also have people from the Red Hat. I also hope some people from Google, because all those group of the people used to be contributed, I believe, and NVIDIA also have some people want to know. So we have this new temporary resource management work group to form and review this new proposal.
Okay, I understand.
Okay, any other question? Any other suggestion, proposal? Okay, that's all for today.
I started to have a feeling what probably in next, well, I cannot promise for next week, but maybe week after, I will need to do a presentation to share a project what I was working on, which touches always like CPU, memory, and device policies. and at least share our experience. I'll probably add it to agenda.
Sure, sure. Looking forward for that. Yeah. Yeah, Chris, thank you for come here and give this presentation and really
Thank
good
you.
discussion. Yeah. Okay, I think that's all for today. Thank you everyone attended today's meeting. Bye.
Thank you. Bye.
Thanks.
Bye-bye.